We will now show you how to display our interactive WRR data. Using the level adjusted and calibrated enhanced LMA signal, we can now click on WRR from the drop-down menu. A pop-up menu appears titled Reference Scan Length in unit of millimeters. Note, the reference scan length is typically chosen to be equal to the rope lay length. The lay length is approximately 6.25 to 6.5 times the rope diameter. We know previously that the rope diameter was 32 millimeters, so I will use my calculator and enter 32 millimeters. I will then multiply it by 6.25. Notice that that equals 200 millimeters. So I will enter 200 millimeters and hit OK. Once the data is entered, a new figure appears showing the enhanced LMA level adjusted and calibrated signal. The green signal, writing on top of that, is referred to as our maximum BLMA signal. For more information on that signal, please refer to the paper cited previously. Next, down below is our WRR signal with a skyline plot writing above, which is essentially a reference envelope of the WRR signal. I can adjust my axis scaling as necessary. For now, I will just hit OK and accept. Note in the middle of the graph is a slider which refers to as scan length in units of millimeters. This is the same scan length width that we had entered previously. Note the 200. The slider allows us to go to roughly 1/100th all the way to roughly 5 times the scan length that we had previously entered. Please note that this slider tool is currently under development and that we encourage you to discuss the use of this tool and the associated results with an NDT Technologies engineer. Similar to the broken wire discard criteria specified in ISO code 4309, we chose 1 and 5 lay lengths, respectively, as appropriate reference scan lengths. Note that the wire rope roughness signal shown on the y-axis is calibrated together with the LMA signal also as a percentage of rope metallic cross-sectional area, or %WRR. Before I use this interactive tool, I want to draw your attention to the LMA signal. Notice that at roughly 3 and 5 meters, looking at the x-axis below, you'll see these dips in the signals, here and here. This signal indicates winding on drum damage with a superimposed higher frequency signal, which is caused by corrosion pitting. At roughly 23 to 24 meters, you'll notice a dip in the LMA signal. This is referred to as corrosion-assisted LMA. Note that corrosion products do not show in the signal, but instead you do see a loss of metallic cross-sectional area, as well as the higher frequency corrosion pitting. We will now investigate the interactive slider tool. I can use this tool in a number of ways. I can start by clicking on the right or left arrows as shown here. Notice small changes in the signal. I could also click within the slider window as shown here. Notice that it will update the value shown in the window. Or I could click and drag to a new location. It'll update that as shown here. Notice as I'm changing the slider tool, you'll see differences in the BLMA signal writing on top of the LMA here in green, as well as the WRR signal here shown in black. Finally, I could highlight and enter a value. I'll go back to my 200 value and hit enter. It'll go back here. So again, you can use the arrows at the edges, slide the actual tool, or enter a value. Note that you can also go to the zoom sections here. For example, maybe I would like to zoom in on this roughly 5 meter section and still use the tool as shown here. 300, 400, 500. Notice there is a slight pause as we move the signal, as there is a lot of data that is being processed. Your patience is appreciated. I can then go back to the overview plot. I will scroll all the way to the right, which will be roughly 5 lay lengths. Note that a scan length of 5 times the lay length shows more or less the full winding on drum damage in the WRR trace. As I scroll to the left, notice what happens to the WRR signal. More of the high-frequency data can be seen, which would be more of the corrosion pitting. I can bring the signal to roughly 1/10 of the original scan length, and notice that the WRR signal is essentially going away, essentially meaning that the max BLMA signal and LMA signal are one and the same. I'll bring it back to the actual scan length of 200, and when I'm done, I will simply click Save WRR Setting. Note that when the file is saved, within the title, you'll see the actual scan length selected, and also on the y-axis here, as well as for all of the zoom tabs. Also in the log area, you will see the scan length recorded. If you wish to save various scan lengths, you could go back to WRR and redo this and save different scan lengths. That way you could have files saved that could focus in on, for example, the full winding on drum damage or more of the higher frequency corrosion pitting. This concludes our analysis of our interactive wire rope roughness feature.